Hi guys, so today we're gonna be discussing electrical circuit. Um, so we're gonna use Ohm's law to solve electrical circuits. So we're gonna do series, parallel, and series parallel, a combination of series and a parallel circuit. So the formula for Ohm's law is, let me just write it this way: it's voltage is equals to current times resistance. Current times resistance. This is Ohm's law. This is Ohm's law. I'm going to explain what does the Ohm's law stand for. So when you multiply the current and the resistance, it will give you the voltage in volts. So this, it's volts. This, the SI units, it's ampere. Then this one, it's ohms. This is the SI units. So they normally write it in this way. So this one you just write A. Then this one you just write V. That V means volts. Then the SI units for current, it's ampere. Then the SI units for resistance, it's ohms. Then you just need to know that resistance is inversely proportional. It's inversely proportional to the current. It's inversely proportional to current. And the reason for this is that when you've got the higher resistance, it means your current drops. So the higher the resistance, higher resistance or higher resistor value, the lower the current value. So when you increase the resistance, the current drops, and inversely proportional. So meaning vice versa. So if let's say your current is high, the resistance will be lower. So they are inversely proportional. Okay, so that's what it means. When the other one increases, the other one decreases. That's what that inversely proportional means. It means when the other one decreases, the other one increases. When the other one increases, the other one decreases. So they are not directly proportional. So when one increases, the other one decreases. Then voltage, you see from the formula, V is equal to IR. Let's say you want to increase one of this. Let's say increase any, whether it's current or resistance. If you increase any of this, let me just write increase. When you increase any of this too, whether it's resistance or current, remember the voltage will also increase. This guy here, this will also increase. I'm going to give you an example. Let's say a circuit with a resistor of 47 ohm has a current flow of let's say 2 amps. You see, I wrote the current as amps, then your resistance is 47. Okay, then they say calculate uh, calculate the voltage across the resistor. The voltage across the resistor. So this is just a simple circuit. So it's more like a circuit like this. So and then it's a series circuit. So that resistor, will name it R1, which is equals to 47 ohm. That's your resistor. Then you've got, I'll just write it as amps. That's your current. So you've got a current flow of I is equals to, remember I is the represent current, so you've got 2 amps there. And then they want voltage V1. So whatever the voltage across that resistor R1 is equals to that voltage there, because it's only it's only one resistor. So whatever voltage is across that R1 is equal to the total resistance, total voltage, because there's only one. So to calculate the voltage, you're gonna say V is equals to I times R. Then you're given the I, which is 2 times 47. So you're gonna multiply these two. So when you multiply these two, your total voltage will be equals to 94 volts. So the whole point of me doing this is to show you that whenever you increase any of this voltage, current or resistance, your voltage will increase proportionally. So what I'm saying is that any increase in any of these two, current and resistance, will also increase the voltage. So current and resistance, they are directly proportional to voltage. Voltage is directly proportional to current and resistance. So when any of this, whether it's resistance or current, increases, when any of this increases, it will also increase the voltage. So let's say you change that 2 amps, for example. Let's say you decrease the current to 1.5 amps. You see that it's going to affect your voltage. So if you change this to 1.5 times 47, it will decrease the voltage. The voltage will be lower than 94 volts. So any change in current or resistance, it will also affect your voltage. So yeah, that's how we do it. Okay, that's all for now. So we're gonna do series, parallel circuit, and also series circuit. So before we do that, okay, so normally they call this resistance that I was referring to from this equation, they call it external resistance. For sure you will see when they say external resistance. And the reason why they are saying external resistance is because when we go to the applications of this electrical circuit, you'll have internal resistance. So this one they call it external resistance. The resistor that you find on your circuit, so like a circuit like this, the resistor